Hi, folks. Today's topic is spheres. So pretty straightforward. We're not going to get too in depth with spheres. I want to do some three-dimensional graphing in the next unit. So this is kind of a nice little lead in. So we've got this a sphere. What's the difference between a sphere and a circle? So hopefully you remember that a sphere is three-dimensional where a circle is only two-dimensional. So our goal by the end of this, we should be able to convert given some information about a center and a radius, we should be able to come up with an equation for the sphere with a given center and radius. And then we should also be able to take a function that's not in standard form, and this is general form, and be able to figure out what the center and radius is by manipulating this equation algebraically. So pretty straightforward. If our center is h, j, and k, this is called the x coordinate. Let me kind of highlight that. In two-dimensional space, we have an x and a y. In three-dimensional space, we have an x, a y, and a z. So we have now a third dimension, a third direction that we can go. I'm going to go grab a manipulative. Hold on a second. So I think this is a nice little applet that we could look at to kind of get an idea of what three-dimensional space looks like. So you have your x and your y-axis, just like usual. So you see the little x there? We have our y-axis here. So if we were graphing like we were in middle school, that's what it would look like. You'd have your x-axis and your y-axis. Now we have a third dimension. We have an x-axis, we have a y-axis, and then we also have a z-axis. So there's just kind of an intro. We're going to hit this again with the next lesson in much more detail. So this is pretty much just algebra and plugging and a chugging. So this is pretty straightforward. Find the equation for the sphere with center 2, -3, -4, and 3. So this would be my h, this would be my k, this would be my j. Now notice this is the radius, and in the equation, all those radii are getting squared. So plug and chug. Our equation would look like x minus h would be 2, quantity squared over radius squared would be 36, plus y. Now I'm subtracting a -4, so that actually turns it back into a positive, over r squared plus z, take away 3 over 36 equals 1. Pretty straightforward. Why don't you try the next one? I'd encourage you to pause here, see if you can do the next one on your own. All right, let's see how you did. This part should be, you're just plugging and chugging. I'm not even going to write the h, k, and j this time. X minus 1 squared over. Now, this is where it takes a little bit of work. You're squaring 4√3. That means I'm going to square both of them. So that would be the same as 4 squared would be 16. Square root of 3 squared would be 3. You're going to cancel the square root around this one, but this number also needs to get squared, so we should get 48 over 48 plus y subtract 5 squared over 48 plus z plus 2 squared over 48 equals 1. It's nice to be able to write your x, y's, and z's in their fancy-looking format so you can keep them separated from 4s and 2s, but it's up to you. As long as I can understand what you're trying to say, we're good to go. And then lastly, let's see the last section here. Okay, so this is where I'm given an equation. This is called general form, when we don't have any fractions and everything is pushed to one side. And we want to get it to look like this, because if we can't tell where the center and the radius is until we get our equation in standard form. So we're going to do that move called completing the square. We did this a while back in first semester, and then we do it a little bit with our conic sections. So I'm going to organize my x stuff, my y stuff, and my z stuff together. And I'm also going to put in blanks. So I've got 5x squareds plus 20x plus a blank plus 5y squareds, subtract 10y, plus a blank, plus 5z squared, plus 40z, plus a blank, equals, and then remember, you want to move all the numbers, the constants, to the other side. So when I move this over, it's going to become a positive 255 plus a blank, plus a blank, plus a blank. Now, the second thing you need to remember is that when you want to complete the square, we cannot complete the square unless this coefficient is a 1. So I now need to factor out a 5 out of this piece. So this would look like 5 times the quantity x squared plus 4x plus blank, plus 5 times the quantity y squared minus 2y plus blank, plus 5 times the quantity z squared plus 8z plus blank equals 255. Now, these blanks all have a 5 in front of them, so I need to go 5 blank plus 5 blank plus 5 blank. Now, there's some shortcuts, but I'm not going to show you the shortcuts. It's really not worth it as much as I expect you to be able to do. I want you to practice your completing the square more than I want you to actually come up with any quick ways to do this. This is probably one of the least hit topics for this section. Okay, so let's remember how this works. So I'm going to take out the 5. That's my constant. And then what do we do with this number to break it down here and bring it back up there? Hopefully you remember that we cut it in half, so this becomes x plus 2. Then when we square, that reminds us to square that number back up here to 4. So this divide by 2, this to the power of 2. That's my little caret symbol. I don't know if it looks like it, but that's what I went for. Plus, now I've got my next group. I'm going to do the same thing, but I'm going to do it for the y's. So we need to cut it in half. Trying to get a good color. Maybe a nice blue here. So I'm going to divide by 2, and then I'm going to square it back up here. So that would be y. Cut in half would be -1. And then squared, -1 squared is still 1. Plus 5 times the quantity. Maybe this. Nah, let's do it. Can never decide. How about a nice green here? Kind of already did a green, but we'll have to live with it. Z, cut this in half, then square it. So 8 cut in half is 4. And I square it, and we'd end up with 16. I wish that I would have used the colors on, I did on that one. I didn't on that one, so the rest are good. Then, these blanks correspond to these blanks, so I want to make sure that all the blanks have the same numbers in them. And then I'm going to grab my calc. I'm going to do this off screen. 255 plus 5 times 4 plus 5. I could probably do this in my head, but I'm going to use my calculator instead to get 360. All right, now what's wrong with this? This is not in the same format as these. They're supposed to equal 1. So what I can do to equal this to 1 is to take everything and just divide it by that 360. So I'm going to divide this side by 360. I'm going to divide this side by 360. Now, the 5 and the 360 can reduce, so I can split these back up into their individual terms. So I would have I would have the quantity of x plus 2 squared over 360 divided by 5 is 72. Plus y minus 1 squared over the 5 and the 36 reduce again. I get another 72. Z plus 4 squared reduces again to be the 72, and that equals 1. Now, I was almost going to box that in. That is not what they asked us to find. All that work got us to a place where we can actually answer the question. The question was, what's the center and the radius of this sphere. So the center, remember, the only thing you got to be a little careful of is that when we put the center in, the sign switches. So we're going to take out the sign switching again. So that's a +2. That's going to become a -2. -1 becomes a +1. +4 becomes a -4. My radius, now be careful here. This is not r. That's r squared. So we've got to take this number. We've got to square root it. I'm going to go do that over in the margin. So I want to square root 72. Hopefully you know square root of 72 is not an acceptable answer in pre-calc. You got to clean that bad boy up. So I would rewrite 72 as I start going through the list. 4 times, let's see, 72, I know it goes into it, 18. Now, is there another perfect square that can go into that? Yeah. Or is that prime? No, I'm sorry. Is this not prime? If this can be broken down again, then you should probably keep checking. So I'm going to try the next perfect square, and I can do that one in my head. The next perfect square is 9. 9 times 8. This can be broken down again, or you can think about it, is there a perfect square that still goes into 8? And if there is, you can find a better choice. 72 is not divisible by 16, so that's out. I know it's not divisible by 25, and yep, 36 times 2. Now look, 2 is prime, so we can't go any further there. So now I want to square root this thing. And who gets to escape? The 36 gets to escape and becomes a 6, and the 2 gets left inside. So then my radius isn't plus or minus. Now, you should have done plus or minus. Oh, no. You don't have to worry about plus or minus because radii only, there's no direction when you talk about a radius. It goes all directions. So we're going to square root 6, square root of 2, box it in, put it up on the fridge. So a nice, pretty easy start to Unit 9. Actually, the first two sections in Unit 9 are pretty good. All right, go get that homework. Good luck.